This lesson is looking at growth and decay problems to do with exponential functions and logarithmic functions. Okay, so this first example is an example of population growth. So it says a farmer monitoring an insect plague notices that the area affected by the insects is given by A in terms of n equals 500 times 2 to the 0.6 n hectares, where n is the number of weeks after the initial observation. So draw an accurate graph of AN against n. So all you need to do for A is just sub in a few values. For instance, when n is 0, you'll get A0, which is 500 times 2 to the 0. 2 to the 0 is 1, so that's just 500. So we're actually starting at 500 when n is 0. When n is 1, or let's go up by 2 since the n-axis is going up by 2s. So when n is 2, A2 equals 500 times 2 to the 0.6 times 2 is 1.2, which equals 1,148.69, blah, blah, blah. So we'll round that to 1,149. So that would be around, let's say here. And let's just keep putting in when n is 4. I don't really need to write n is 4. I can just write A4 because that actually tells me what n is. So we get 500 times 2 to the 0.6 times 4 is 2.4, which equals 2,639. So I'm jumping up quite a bit. So since I'm already up here, I don't think I need to put in any more n values. So that's the graph there. Of course, you can always graph it on your calculator as well, but of course, we need to be able to do it without that too. So that's the graph. B. Use your graph to estimate the time taken for the area to reach 2,000 hectares. So I want my area to be 2,000 hectares and I need to find n. So I put 2,000 where A is, so I get 2,000 equals 500 times 2 to the 0.6 n. Now what I can do first is divide both sides by 500. Cancel, cancel. 2,000 divided by 500 is 4 equals 2 to the 0.6 n. Now I'd like you to first try this without a calculator. Hopefully you realize the left-hand side is just 2 squared. So 2 squared equals 2 to the 0.6 n. And since now I've got the bases the same, I can just say 0.6 n equals 2. I can equate the powers. Divide both sides by 0.6. Cancel, cancel. And you get 3.3 recurring. So now we can say it would take 3.3 weeks for the area to be 2,000 hectares. Now, what we also could have done, instead of doing it that way, let's just say this number here was like a 6 or something that we couldn't easily get in base 2. Well, from this step, what I could have done is done the log base 2 of both sides. So I could do log, actually no, I don't even have to do base 2, apologize. I could just do log like base 10, whatever I want, log of both sides. And what happens with the power? That power jumps to the front, so I end up getting log of 4 equals 0.6 n log of 2. Okay, now I've chosen to use base 10, you could have chosen to use base E. Either one is fine. Then if I divide both sides, remember I want n on its own, so I need to divide both sides by 0.6 to cancel that out, and log 2 to cancel that out, and so I'm left with n by itself. What you do to one side, you have to do to the other. And finally, you get n is, if you put all that in your calculator, you should get the same as before. You can check that now. And having just done that myself, I did see that I still got 3.3 recurring weeks. So I just wanted to show you that was another way to use logs to solve your equation if your left-hand side number wasn't a nice power of 2. Now I just realized part B was actually saying use your graph, not the equation. So now if I look at this, use my graph, and to reach 2,000 hectares, so I find 2,000 on the hectares, the area axis, go across and down. Now I'm hitting it there. Now we can imagine 3 is in between here, and it's around halfway between 3 and 4. It looks like it's more like 3.4 approximately. So using the graph, I would estimate around 3.4 or 3.5. Now, it's not surprising we don't get it exactly because it's just a rough graph and our grid wasn't the most accurate. So using my graph, I would estimate 3.4 weeks. Now C is actually saying check your answer to be using logs. That's actually what I did first. Sorry about that. So that there is C using, B using the graph. And this over here is actually C. By actually trying to solve the equation for when A is 2,000. And also hopefully you realize that if you graphed this on your calculator, you could trace your graph and find when it equals 2,000, and that's another way to estimate how long it would take, and you should get about 3.3 weeks. Question 2 is a financial growth question. It says, Jane has $6,000 to invest in an account that pays 4% per annum interest compounded annually. How long would it take for her investment to reach $24,000? Now, I just go back to the plain old compound interest formula that you've used since year 10, which is A equals P times 1 plus R to the N. So here, the principal is 6,000. The rate is 4%, or better as a decimal, 0.04. The interest is compounded annually, so I don't have to adjust anything. Everything is already in years. And the A is 24,000. So if we put all that in there, we get 24,000 equals 6,000 times, I'll write it first as 1 plus 0.04, but personally I like to write it as 1.04. to the N, because I'm trying to find how long it will take, so I'm trying to find N. So first step, hopefully you can realize we divide by the 6,000, the multiplier. Cancel, cancel. And we get 4 on the left equals, now hopefully you don't mind, I'm writing inside the brackets as just 1.04. You don't have to, you can keep it in brackets, but I like to write it as one number. And because it's one number, I don't need to include brackets anymore. And then it's to the power of N. So now to work out N, I do log of both sides. Again, you can use base 10 or base E, up to you. I automatically just go log the base 10. So I'm going to do log of this side, log of this side. And what happens? Well, I just get log of 4 equals, the power goes to the front, which is why we're using logs. We're trying to get the power out so I can then isolate it or make it the subject. So I get log of 4 equals N times log of 1.04. So now I can divide both sides by log of 1.04. Cancel, cancel. And I just put this in my calculator to find N. Now, as a decimal, I get 35.35. Now, that means it takes 35.35 years. So, but I'd like to try and write this as years and months. So first, I'm going to write, therefore, it takes 35.35 years, or you could even say 0.4 if you round it to 3 significant figures. But I would like you to take some time now and think what would that be in months? Now, the 35 is the years. To find the months, we're just going to use the 0.35. So, to work out the number of months, we would use that 0.35 and times it by how many months in a year? 12. So you can get the decimal from your calculator, times it by 12, and I get approximately 4.2 months. Oops, months. Months. So therefore, you could even say it would take 35 years and technically, let me just think for a second. Technically, we want to reach 24,000. So if it takes 4.2 months, I need that extra bit of month to get there. Otherwise, it won't get there. So you could actually round it up to 5 months, or you could just leave it as 4.2 months. I don't think they would ask you to be any more accurate than that. So that's just a way to work out the years and months if you want to. Get your decimal part of your answer. Get the decimal part of your answer and times it by 12 to work out how many months. But in general, I think your original question, unless they asked for it in years and months, as long as you rounded this answer to at least 3 significant figures, I believe that would be sufficient. Okay, so girls, now I'd like you to try exercise 4H, and that's it. Thank you.